This is the Spicy 100, question 13. The recommended time for question 13 is 5 minutes. I'll read the question to you. The functions f of x and g of x are defined that f of x is equal to sine x and g of x is equal to cos x, where x is measured in degrees. Solve the equation f of x subtract 2 is equal to g of, open bracket, x plus 90 in the range from x from 0 degrees to 360 degrees. When you're ready to make a start, you've set your timer, pause the question, and best of luck with number 13. So in question 13 we have two functions and they're your trig functions, sine x and cos x. And then we've got to solve an equation where we've got f of x subtract 2 is equal to g of x plus 90. Now this reminds me of graph transformations, and actually I think that's the trick for me that I personally would use to do this question. So before we think about moving them around, let's just remember what sine x and cos x look like. Let's consider the function sine x first. So f of x equals sine x. So we draw an axis, so we want a nice longer horizontally for trig normally, so label your axes always. So sine x, we should remember, begins at the origin, so it starts at 0, comes up, we get this shape. So the key values are 0, 90, 180, just squeeze those on, 270 and 360. So there's a rough sketch. Now sine has its maximum 90 degrees at 1, and at 270 gets down to -1. So we'd call that the range of the function is between 1 and -1. That is what sine x looks like. I recommend drawing that, and then when you start to consider a graph transformation for f of x minus 2, that will help you to see what that will look like. Okay, let's think about cos x next. So it's a very similar technique. Draw our axes, label them. But cos begins on its y-intercept is 1, so at 0 degrees cos is 1, and it decreases, and then at 360 it gets back to 1. So we've got 0 would be 1, at 90 degrees it's 0, 180 it's -1, 270 back to 0, and 360 gets back to where it began. So cos is it's almost a transformation of sine x. It's been shifted horizontally to the left. So you can actually make a nice little identity out of that. So key differences: sine begins at 0, increases, and its full time period comes back to 0. So cos begins at 1 as a y-intercept, and at 360 degrees it gets back to 1. Now these functions, they travel infinitely in the x-axis, but I've only just considered between 0 and 360 just because that's what the question wanted. So having a reminder of those functions, we're trying to solve the equations f of x subtract 2 is equal to g of x plus 90. So if we consider f of x subtract 2, as a graph transformation, if you were to draw this, if you have to draw y equals f of x subtract 2, we should know that when you have a number on the outside of your function, effectively what you were going to do is you could put your function and then subtract 2 from all the values. So this is actually a translation in the sort of y direction, and so the 0 would be the translation of the x. We wouldn't move it, but we'd move it down 2. So if we consider y equals g of x plus 90, now this as a transformation is in our bracket. So when it's inside the bracket, so g of all of x plus 90, this actually is a transformation in the x direction. And we actually have to apply the inverse. We have to do the opposite of what it looks like it says. So instead of moving it 90 in the positive direction, we actually move it 90 in the negative x direction. As a translation, we're going to move it negative 90 in the x direction. We're going to leave it in the y. So these are translations. So vector translations tells us x and y. So what we're going to now do is draw these translations of these graphs on the same axes, and that will help us to see where the solutions might be, where these graphs intersect would be our solutions. We're going to draw f of x subtract 2, so we're going to translate sine x, we're going to move it down 2. So if we draw a nice big axis, because we're going to go down to a bit further. So key point, so sine x normally is at 0. So if I move it down to, it's going to start down here at -2. And then it's going to go up, down, and I'm going to get my, could do a little dotted line here just to help me see whether how it's been moved down by -2. So I can see here that at 90 degrees, because this has gone up by 1, this will be -1 there. And then at 180, we'll be down to -2 again. At 270, because we're actually going below this -2, we'll be down to -3 down here. And at 360, we're back up to -2, because normally we would have been back up to 0. So that is the translation of sine x down by 2. On the same axis, we're now going to draw cos x if we move it 90 degrees to the left, so in the negative direction. So what I can see here is that normally cos x starts at 1, and at 0 it gets down to 90. So if I was to shift this 90 this way, it's actually going to start at the origin, and it's going to go immediately down. So actually its negative point is now at 90. So it's actually at -1, this point here is at 90. So I can see it actually just touches the curve here. So then we're going to continue the function, so it would come up through 180, and then it would peak at 270, and then down again at 360. And so you can see actually that these two functions, they're only going to go anywhere near each other here. And actually this is our intersection point. There's only one at x equals 90 degrees. Because of these translations, we can see that x equals 90, both functions with the transformations are equal to -1. And so our solution, and there's only one solution, will be x equals 90 degrees, because we can see that's the intersection where both these functions be in the same place. So you needed to be knowledgeable about your trig graphs, you needed to know about your graph transformations, and the idea that where graphs intersect is actually the solutions for the two functions being equal to each other. So I hope you enjoyed question 13. If you're feeling fresh and ready for the next challenge, why don't you go and have a look at question 14.